Hello and welcome to a screencast introducing the sine and cosine functions. In this video we will define the sine and cosine functions, and then we will use the definition of the sine function to create its graph. Previously we saw how tracking the height of a point that is traversing a circle generates a periodic function, and we identified a collection of 16 special points on the unit circle, which you see here. If we consider the unit circle and we start at t equals 0, traversing the circle counterclockwise, then we can view the height of each point as a function of the angle t. That means that the input is going to be an angle and the output is going to be the y-coordinate of a point on the unit circle. When the output is the y-coordinate of these points, then we call that function the sine function. Similarly, we can think about the unit circle again, starting at t equals 0, traversing counterclockwise, and then we consider looking at the x-coordinates. We can view the x-coordinate of each point as a function of the angle t. This means that the input is an angle and the output is an x-coordinate on the unit circle. When this occurs, we have the cosine function. I want to emphasize, this notation is not sine times t or cosine times t. These are names of functions. The sine function has an input that is an angle, and it has an output that represents the y-coordinate corresponding to that given angle. Similarly, the cosine function has an input that is an angle, and it has an output that corresponds to that angle and is an x-coordinate. So let's look at the sine function a little more closely to get an idea of what its graph looks like. We know that the sine function is going to have outputs that are y-coordinates on the unit circle. Referring to the unit circle, we notice that at an angle of pi over 2, the y-coordinate is 1. So we can say that the sine of pi over 2 equals 1. Notice that if we look at the sine wave at pi over 2, there's an output value of 1. This sine wave was created by looking at each angle on the unit circle and plotting the y-coordinate that corresponds to that angle. So when the angle is 0, the sine function equals 0. And this graph goes through 0, 0. When the angle is pi over 4, the y-coordinate is radical 2 over 2. So we can say the sine of pi over 4 equals the square root of 2 over 2. Notice that the square root of 2 over 2 is a little less than 3/4, and on the graph we see that at an angle of pi over 4, the output is a little less than 3/4. One more example we could look at is the sine of 3 pi over 2. On the graph of this sine wave, we see an output of -1, and on the unit circle, at 3 pi over 2, we see that the point has a y-coordinate of -1. So we say that the sine of 3 pi over 2 equals -1. By using the unit circle, we could complete a table of values where we find the value of the sine function at all 16 special points on the unit circle. For now, we see that the sine of 0 equals 0, the sine of pi over 6 equals 1/2, and the sine of pi over 4 equals the square root of 2 over 2. All of these are found by looking at the y-coordinate that corresponds to the given angle input. And we could repeat this procedure to complete this table and graph the sine function by hand. In the next video, we're going to look at finding exact values of the sine and cosine function at other angles, including angles that, at first glance, are not obviously on the unit circle.